Up until 1947, there was only one way of doing tuning. Up until 1947, the only method we had of tuning was trial and error. Trial and error was pretty well, think of a number, put it in, see what it does. And then think of another number. That's the trial and error method of tuning. We're going to go into the details of exactly how the trial and error method worked. But that's all we had. Then a couple of chaps called Ziegler and Nichols, who were working for what used to be called the Fisher Valve Company, they came along and they worked out two methods of tuning. And they worked out the Ziegler-Nichols open loop bump method, which is called Ziegler-Nichols number 1, and the sustained oscillation method, which is called Ziegler-Nichols method number 2. Now, these two systems, they didn't work them out using some sort of supercomputer and mathematical modeling, because they didn't have supercomputers and mathematical modeling in those days. They worked them out by just looking at things and kind of trying different numbers and empirically working it out. In other words, they pulled numbers out of the air. So, there's the three methods. The trial and error method is a closed loop method. In other words, we have the system in auto. The open loop bump is an open loop method, so we have the system in manual. The sustained oscillation method is another closed loop method, and we have the system in auto. Another thing to tell you about it, any closed loop method relies on oscillation. So the trial and error method relies on oscillating. The sustained oscillation method, well, you better believe that relies on oscillation. What that means is, in the field, in a factory environment, in a real-life environment, you are not allowed to use the trial and error method. You are not allowed to use the sustained oscillation method. The reason you're not allowed to use those is because you are not allowed to oscillate real systems. Having said that, I'm going to teach you how to use all three methods, and there's a reason for that which will become plain to you a little bit later in the course. So just remember, the only method you are allowed to use in the field is the open loop bump method. So moving along, let's have a look at these three different methods. The first method is the trial and error method. With this method, what you do is you get rid of the I term. Normally that means you stick a 0 in the I. You get rid of the D term. Normally that means you stick a 0 in the D. And then if you've got a gain, you make it a small value. So you make the P value very small. And you see what it does. If it oscillates, then you've gone too far. If it doesn't oscillate, then you double it. So you make the P term 0.02. And you see what it does. If it doesn't oscillate, you double it. So you make it 0.0, so make it 0.02. You make it 0.04. Is it oscillating? No. Double it. 0.1, double-ish. Is it oscillating? No. Double it. 2. Is it oscillating? No. Double it. And you carry on doubling it and doubling it and doubling it and doubling it until it oscillates. Let's say for the sake of argument we've made it 4 and it's oscillating. As soon as we've got it oscillating, you back it off and you make it 2 again. You may actually have to back it off all the way to 0.5 and then bring it back to 2, because once it's got oscillating, it likes to oscillate. So you increase it, increase it, increase it, increase it until it oscillates, and then you back it off. And then that's your P term found. Now we go to the I term. Now if it's an I term, if it's a time, so if it's I time, or TI, then bigger does more. So we make it a big number. I don't know, let's pick a big number, say 1,000. And we look at it, does it oscillate? No. So we make it smaller, so we halve it, make it 500. Does it oscillate? No. So you halve it again, 250. Does it oscillate? No. And we carry on doing this until, say, we get to 30. Oh, I probably won't get to 30. So we get to 20. If we get to 20 and it oscillates, then we say, oh, okay, 20 made it oscillate, so I'll go back to where I was last time, which would be 40. So there we go. I've got a gain of 2 and an I term of 40. And that's it. I found it. Now what we've done here is we found the P and I values, because what we're trying to do, remember, is we've got these 3 boxes in our PLC called P, I, and D. So now we go to our PLC and we found 2, so we'll stick that in for the P. We found 40, we'll stick that in for the I. Now, in almost every circumstance, we would just leave the D alone and just stick a 0 in for the D. But if you're crazy and you want to stick a D in, then you do the same as you did for the I. You start with a big value and you work down. Personally, I would recommend you just leave a 0 in there. You almost always will. So that's the trial and error method. The reason why we're not allowed to use the trial and error method in the field is because on 2 occasions now, we threw the valve into oscillation, and you're not allowed to oscillate real things. I mean, I can't emphasize this enough. You can imagine, if you went up and said, do you mind if I just oscillate the nuclear reactor level? No one's going to be very happy. So we're not allowed to oscillate real things. Most valves are pretty big. Oscillate them for a couple of minutes and you've stuffed the valve up. So that's the trial and error method. It's a closed loop method. We do it in auto. In order to get it to do anything, I should just mention that you have a thing called the set point. If you have to put a set point value in, otherwise it won't try and do anything. So always remember to have the loop in auto and to enter a set point.